Thank you, Charles. So I think we have one question for Peter Holzer, and we have a question for all the presenters. So I can share my screen now. And we can start from the question to to Peter Holzer. So can you see my screen, Peter? Okay. So how about using air exchangers following the process of adiabatic cooling, where we can cool the warm air by simply passing through these air exchangers, which can have a closed loop of water circulation, hence lower air temperature can be achieved?
The French thermal regulation use a lot of system, including a lot of system. This system must be designed in a previous phase of building. So thermal regulation can simulate this type of heat exchanger if the input parameters are no. So is it possible to use heat exchanger in this French thermal regulation?
And from my side, the answer is yes. It's for sure a good idea to use the air exchangers always, as long if outside temperature is higher than inside temperature. In case of night ventilation, I do hope that outside temperature is lower than inside temperatures, so the air exchangers have to be passed by. So this is our principle. We always use heat exchangers in our ventilation systems, and for night ventilation, we certainly pass them by if going for mechanical solutions.
Okay, thank you, Peter.
Just the strategy of cooling by direct by external air or by heat exchanger is done in the design phase. So in French thermal regulation, is it possible also to choose the strategy in accordance with the design phase?
Okay.
Thank you, Charles. There is also a question for you, Charles. I guess you can see my screen. So is there a measure of overheating in RT 2012? For example, Austria regulations mentioned that max allowable temperature was 27 degrees.
The thermal requirement for comfort for the summer comfort is done, yes, in French regulation. There are two simulations, one on the project and the other one on the reference building. And the summer comfort temperature must be lower in the project than the temperature in the reference building. So this is a requirement as presented in the first or the second slide. There is no value of temperature, but it is always a there is a reference building with the temperature, the summer comfort temperature T12.
Okay, thank you, Charles. There are another 3 questions for you. So can you confirm both examples were in low consumption building?
The examples are in accordance with the French regulation at 2012. The level is more or less BBC, yes, low energy building. Concerning the mechanical ventilation, or the extra ventilation. This is an example also only to explain the how we can take into account the extra ventilation in the French regulation. This is only an example. Concerning the thermal inertia are taken into account in French regulation. In the Comet core, there are three types of inertia: the daily inertia, the sequential inertia, and the annual inertia. So inertia are taken into account in the French regulation.
Okay, thanks. And how likely is it for dynamic simulation to be part of regulations for assessing the effects of natural ventilation?
The calculation is made on 1 year, and the time step is 1 hour. There are not the effect of natural ventilation is taken to account in a global requirement of CEP for consumption and also for thermal comfort. So all the parameters of the building are taken into account in the French regulation.
Okay, Charles, there is another question for you. So why using a simplified formula to estimate flow rate through windows and not calculating the flow rate according to the internal pressure?
We use a simplified formula to estimate the flow rate through the windows, and we use a model with internal pressure to determine the leakage through the wall. So we have to approach a simplified approach for the flow rate through the windows, a more complicated approach for the leakage, for the flow rate through the leakage. Yes.
Okay, thanks. So we also have a question for all our presenters. Are you aware of the new standard in preparation ISO 52016 which is succeeding ISO 13790? With this standard, hourly calculations can be made and directly compared with monthly calculation method without more input data.
Yes, you know, RT 2012 is already applied in France, and French ministry don't want to change this regulation at this moment. So yes, we follow the European works on the new norm and new standards. So we can follow, but it is not at this moment. It is not. The French ministry don't want to change the French regulation, the French thermal regulation.
And if I may join in, is that okay, Maria?
Yes,
this is Peter speaking. So my answer is yes. We are aware of that new code. It's in the sketch phase since March in Austria, so it's available in the sketch print, and we're doing the first parameter studies on it. So I put hope in it, sure, and it will prove if it manages this balance of having standardized input parameters against knowing it better as an engineer that is very deeply into the specific building. So I think it's a balance that has to be found between knowing each of the input parameters by my own and having the standardized approach to have it comparable. So I put hope in it. Yes, I'm aware of it, and we're testing it right now.
Thank you, Peter. And what about Per? Per, would you like to
for Denmark, I can see the situation is the same as in France, that we are aware of these new developments in the standards, but at the moment there is not any interest by the Ministry or Energy Agency to change the existing procedure to another one. So, yes, this is the situation.
Thank you, Per. Well, I don't think there are more questions, Alexander. Or maybe we have a comment which says, I feel monthly calculation can't fit for ventilative cooling.
Yes, I am always, yes. The ventilative cooling must be done at a time step of 1 hour. You know, in climate file in the French regulation is done at each hour of 1 year. And in this climate file, there are temperature, humidity, but also wind and wind speed and orientation of the wind.
Maria, I've just copied an additional question. Just a reminder to people who ask questions, always send it to all panelists. If you don't send it to all panelists in the Q&A, we might miss it. Okay, Maria, thank you.
Okay, so I think, are we talking about this question, Alexander?
No,
so average.
No, that was from before, sorry.
But there is still another question
for
no, I guess this is for everyone. So average monthly calculation don't represent enough the dynamic problem of overheating. Can you explain more your difficulties? I'm sorry.
Yes. As already said by the previous presenter, the difficulty is to take into account the effect of the wind, and the effect of the wind must be done at each time steps in our code. So I think it is not very efficient to have a monthly calculation. So this is the reason why the French Ministry take into account the time set of 1 hour.
Thank you, Charles. We also have another question for Peter Holzer. So isn't it possible to use the approach for heat pumps of the monthly balancing approach?
I think that the answer is a careful yes. I think that's a brilliant idea. I never saw it in application, but yes, for the heat pump question, we use that approach of looking at deriving a daily temperature out of the monthly temperature, and then overlaying a temperature run through the day. So we do artificial hourly values out of the monthly temperature values to get the COP of the heat pump correct. And this would be an idea to use this temperature, this artificial hourly temperature, for overheating calculations to Yes, it's a careful yes. I never tried it, and I don't see it in our codes, but I think it's a good idea. And yeah, thanks for that.
Thank you, Peter. And there is we should go back to another question, which was intended for Per Heiselberg. So Per, this question, average monthly calculation don't represent enough the dynamic problem of overheating. Can you explain more your difficulties? Was initially intended for you. So
okay.
would you like to comment on that a bit more?
Yes, I think we all agree that average monthly calculations are not useful for predicting the cooling need or neither the overheating risk. I think that the reluctance by the ministry to change to a dynamic simulation tools is because when you go from mean monthly to dynamic simulation, you need to define, you could say, more input parameters like occupancy profiles, heat load profiles. You need to have more specific weather data and so on. So it does represent a larger effort from the design team if you're using a simulation, a dynamic simulation tool. So I think that's the difficulties seen from the and the other issue is that it might be more difficult for the authorities to check the calculations. The more a complicated model you use with more input parameters, the more difficult it is to check that the prediction and the outcome is correct. So I think these are the issues that they are, the reasons why they are reluctant to change the compliance tools to a more detailed one.
Okay, thank you, Per. There is also, it's not a question, but it's a piece of information for all of you. So it was displayed in the chat panel, and maybe I can read it out loud. So there is a study for DEME in France on ventilative cooling. First, a lot of buildings were said to be with ventilative cooling, but we had some difficulties to find 10 running. We are monitoring 7 buildings. 3 finally were not running, and we had a very hot summer last July. We're now looking at the results, but it appears a lot of practical problems reducing the actual efficiency of ventilative cooling. So poor installation, lack of information of users, and mistakes in design were made. Whilst theoretically it could save a lot. A few sites are running properly, though. After analysis of results, the study aims at preparing guidelines for designers. This was just a comment from an attendee.
Yes, thank you.
And there is a last comment, which is here displayed in the Q&A panel. The arguments regarding more input data for hourly are not correct. We still have a work to do to explain.
May I answer on this, or may I comment on this? Peter is speaking.
Of course.
This comment is in principle, I think it's correct, yes, as long as if you standardize the input parameters very strictly. So, for example, the usage patterns, how many people are in the office for how many hours, in which patterns of the day, how many computers they are using, efficient computers or not efficient computers, and so on and so on. If you standardize everything hourly, the input parameters, for example, internal load and usage patterns, then I'm totally with you that an hourly calculation method is not more an effort for input than a monthly method. But as soon as you try to picture the specific situation in a building you are designing, then it's a lot of more, let's do not call it effort, but chances to picture the thing which is really happening in the building. And then it's a lot of more chances and options and efforts. And I'm with Per that then it gets difficult for the authority to compare the results. So I think the answer is yes, you're right. It's not a bigger effort necessarily, but if you take the chances it offers to the design, then it gets very variable, the thing. So I hope, that's my point.
Thank you, Peter.
There's a couple of comments. I don't know, Maria, if you want to share them or just pass them on to presenters in writing.
I'm not sure if I have the comments that you're referring to.
There's one from Mr. Dick van Dijk from 11.25 on the approach, like heat pumps.
Yes, exactly. We have this one, but Alexander, besides this one, we don't have something, right? Do you have something in your private?
No, nothing more.
Okay. So there is this comment for all the presenters. I don't know what was exactly meant by using approach like for heat pumps. Please be aware that in buildings the accumulation of heat is large, so a bin type of method cannot be used for buildings.
Mm-hmm. Well, since I took that answer, I take it again. It was not the idea to use statistics of temperatures, but to create a synthetic hourly temperature flow during 1 month by just taking the monthly mean temperature. So to create an artificial temperature run out of the monthly mean. I think it's another approach to get it better, but again, in this simplification, to have only 1 monthly mean and then to create an hourly flow of temperature during the month, it can lead to difficulties too. But that was the idea, to create a synthetic temperature profile during a month by taking only as an input variable the monthly mean. That was the idea, not to do statistics on temperature.
Okay, Peter. I think there are another 2 comments. Just comments, no questions. So I think this was intended. This is a comment while you were speaking. So I agree that you have to standardize the user pattern, and now these user data are already standardized on the background of the monthly procedures, but not visible and transparent.
Yes, Mr. Hogeling, you're right again. Still the user data are now, we are fine with sums or with average values, so with watt per square meter average heat load from users. And if we go for hourly calculations, we do not have only the option, the options wise, we do not have only the options to put a mean value for the heat load, internal heat load, but we have the chance to think about the time patterns, and the time patterns will be different from building to building. And yes, if we standardize the time patterns, then we're in the easy world again. But then we have to lose one option of preciseness again to win one option of comparability. And this question arises when changing to hourly calculations. It has not been arising in monthly calculations. But I'm a friend of hourly calculations. Looking forward.